Hi, this is Marine Radio blog on Q&A, and we have the next question. Let's find out the purpose of the ECDIS.
At the most basic level of explanation, an electronic chart is geographically related information displayed on an electronic screen, such as a flat panel display. Look at the example. One of the biggest drivers at the time was the perceived capability of using optical disc technology, such as CD-ROM, to distribute electronic chart data in a more easily transportable form than a paper chart. By the end of the 1980s, it was clear that the technology was advancing at such a rate that electronic systems with the potential to replace paper charts would become available during the 1990s. This happened due to the development of processors and the monitor screen resolution up to the next level, achievable for the chart plotting task. By then it was widely recognized that there were two separate ways of producing electronic charts. The first is based on storing and displaying the image of a paper chart in a digital format. It is best imagined to be a digital photograph of an existing paper chart. In principle, this image can be shown on the display at various magnification, allowing an overview of the complete chart through to a true scale image that can be scrolled across the screen to show the area of interest. This is known as a raster electronic chart. These days, the term raster is also used to describe an image made up of a high density of dots on a regular grid, each small enough to be of just one color. Each dot is known as a picture element. The term normally shortened to pixel. What distinguishes a raster chart from a digital photo is that each pixel can be given a defined position in terms of latitude and longitude. Therefore, the chart display system can overlay the chart image with other position-related information, such as ownership, position, and so on. The other type of chart is known as a vector electronic chart. This technology is capable of far more sophistication than a raster chart. A chart image is not stored. What is stored is all the basic information about the charted features, effectively as long list. In particular, this list includes all positional information of features and objects in latitude-longitude coordinates. Vector data can describe all objects, not just point objects. This means, for instance, that depth contours are represented by the lines and channel separation lanes by areas. The vector name comes from computer drawing and game development software, where features such as object geometry, aspect, and position need to be defined so that objects and scenes can be displayed as seen from a particular viewpoint. The use of vector mathematics makes this possible. We need to understand if raster data is zoomed into, the image breaks down into its component pixels. The zooming process acts as magnifying glass. But when zooming into vector data, it is not a simple magnification. The symbology remains at a constant size, but the separation distance between objects increases. So, A vector chart is a database of geographical area, and chart equipment converts the vector data to a chart image on the display. This could be to any projection in principle. This is a part of the reason why vector charts are said to use presentation-independent data. Since vector chart data describes the position and attributes of an object, automatic processes within the electronic chart equipment can detect if the vessel is approaching a potentially hazardous situation, such as shallow water, and give a warning to the mariner. This ability is also used for checking the route for hazards as part of the planning phase. Now is the proper time to name what comprises an electronic chart.
There are 5 essential components of an electronic charting system. Here there is a data that comprises the digital chart information. At the same time, ECDIS needs the computer hardware, including the processor, semiconductor random access memory, which we call as RAM, hard drive memory, and optical disk reader. Also, the electronic chart software that is run by the computer hardware. ECDIS is equipped also with the user interface facility, such as the display and keyboard and trackball. In the meantime, the ECDIS system requires electronic interconnections to other onboard equipment. Look at the diagram.
Let's leave some remarks about ECDIS main elements. We have to understand that electronic chart data always must be specially prepared by the issuing body, such as hydrographic office, in a closely defined format that is readable by the specific software within the electronic chart equipment. The preparation of official data always performed by or on behalf of a national hydrographic office. The preparation has many inputs, including, for instance, raw depths and coastline data as collected nowadays by survey vessels, aircraft, and satellites, seabed characteristics, defined positions and attributes of aids to navigation, such as buoys and beacons, for example, from data supplied by coastal authorities. Positions of hazard and where care should be taken, such as underwater cables and pipes, wrecks, bridges, and oil platforms. Unfortunately, a significant amount of the base data is old and paper-oriented, and remains even now a huge headache to transfer to digital format, except as a raster chart. For the original Admiralty Raster Chart service, high-resolution digital scans were made by the United Kingdom Hydrographic Office of special prints of the color-separated printing plates. These were then combined digitally to ensure good color and display characteristics. Vector data is also derivable from paper charts. It is a very much more complicated process than that used for raster data, but it is still easier and quicker than working from raw survey and other basic data. The data, whether raster or vector, typically arrives on the ship on optical discs or another available delivery method, such as file transferring via the internet, and then read by the onboard chart system. In general, only chart data that has been licensed to be used on a particular vessel will be accessible. This is controlled by a digital permit system developed for the electronic chart distribution process. Think about the hardware part. We are concerned that ECDIS is a computer, network-based equipment dependent on intercommunication with a set of additional devices. The speed of operation of the equipment is heavily governed by the speed of the processor and other digital components. The next key element of ECDIS is the software, which is a computer code that governs the complete operation of the system. It comprises the specific manufacturer's code and the operating system. It permanently resides on the hard drive of the onboard equipment. For ECDIS, the complete software functionality will not only have had extensive tests by the manufacturer to prove its compliance with IMO requirements, but will also have had independent tests performed by a flag state approved test house in a process known as a type approval. For ECDIS, the electronic chart software is preloaded by the manufacturer onto the hard drive within the equipment. We have many producers of ECDIS on the market, and their software and hardware parts must meet a set of industry standards. Using ECDIS software, they have to respect the modern life cybersecurity aspect. Furthermore, the unauthorized loading of software to the ECDIS computer can result in a computer BIOS being unintentionally loaded into the system. Also, they have to mention that the interaction of the equipment with the ECDIS user is normally done through the display and other user interface facilities such as trackball, keyboard, buttons, and switches. Talking about ECDIS interconnections, first of all, they have to submit that the great value of using electronic charts is that they are directly connected to the positioning system. Generally, ECDIS is also connected to other equipment, conveniently allowing them to display depth, speed over the ground, speed through water, gyro heading, and other navigational information. Also, the display of radar track target vectors is very common, and sometimes the actual radar image can be overlaid onto the chart display. All this require carefully engineered interconnections, which need to follow internationally agreed standards to ensure compatibility. In the next diagram, let's summarize the data flow process in ECDIS.
Information flow in ECDIS consists of three main tasks. Here we have the input of the information, processing of it, and functioning of the ECDIS. Let's name the ECDIS processing tasks: automatic chart display for actual ship position, chart freescaling, updating of base data, route planning, route monitoring, navigational calculations, ships track recording, messaging and alarming, radar and IIS targets display, local data processing like VTS and AIS. As the main input information source to ECDIS, we have the next blocks of items as chart data, chart updates, positions, user input local pictures, radar and IIS overlay input. Among ECDIS functioning categories, we have the set of functions as chart display, navigation functions, anti-grounding functions, steering orders, event recording, messages and alarms.
ECDIS equipment is counteracting with safe passage of the vessel at sea. It means that the area of ECDIS implementation is strictly regulated to standardize the subject. ECDIS meets a huge legal framework field, which we have to discuss later. But the most important regulation in focus when we talk about ECDIS is the performance standard about it.
The ECDIS Performance Standard is an important document, and it is recommended for the ECDIS user to be familiar with it. Here we will give the structure diagram of the document to demonstrate the value of the document. Later, we will go deeper in details.
This document is recommended for an overview of ECDIS users. In the body of generic ECDIS course, we will go through that important regulation in the next video. So follow us at the Q&A on the Marine Radio blog. And you know what to do after you have watched the video. See you and good luck. This is Q&A.
We'll slide the button for the next question already. But to help us, we need you to subscribe to the channel, and we hope your thumb is rising up for the like